Hello, my name is Deniz Aralan, and today I will be conducting our physics lab experiment, Homemade Inductors. In this experiment, I'm going to measure how the inductance of the homemade inductors change based on the radius and the core material used. Basically, the inductance depends on four things: number of turns, the core material, the radius, and the area of the cylinder. We fixed the number of turns for this experiment, and for each cylinder that we used, we made it 11 turns. This was one of our controlled variables, and our dependent variables became the core material, which was copper and aluminum wires, and four different values of radius for different cylinders. In this experiment, other than the cylinder and the wires, we needed a DC supply, power supply, a multimeter, electronic Gauss meter, and some crocodile cables to form the circuit, and an ohmic resistor. In this experiment, again, we're unable to directly measure the inductance, and that's why we measured the magnetic field first. And the formula we used and interpreted for this was L equals NBA divided by L. As you can see, we used the multimeter to check that there was a current, and when we saw that there was a current, we connected when the setup was done, I brought the Gauss meter closer to the cylinder, and I can see the variable change of the magnetic field's strength. The power supply is also at 1.5 voltage and 0.5 amperes. So this is also fixed in our experiment. After conducting this for one single cylinder, we also repeated the procedure for the aluminum wires, and afterwards we changed the cylinder to another value of radius, and we saw how the values fluctuated and changed dependent on the radii. And overall, we expected for the magnetic field to increase when the material's permeability increased. And as a conclusion, we did get this. So we had some few errors, but overall, our conclusion was as we predicted it was going to be.